Hello, welcome to Unacademy. Today we will see our next lecture on partial derivatives. यहाँ पे हम लोग देखेंगे application of partial derivatives. That is first application here, maxima and minima. Okay, we will discuss one application in this lecture, that is maxima and minima. Before going to start this, let me introduce myself. Myself Dhanashree. I completed my MSc in Mathematics from Mumbai University. I also mentored more than 10,000 plus students in the engineering and also having 13 plus years of teaching experience. Now, let me introduce how to install the Unacademy's Learning app in short. So first, go to your mobile's Play Store app, then search Unacademy's Learning app and then install the Unacademy's Learning app. आफ्टर दैट यू हैव टू मैनेज योर गोल हियर. जैसे कि हम लोग अभी यहाँ पे गेट एंड ईएसई के लिए पढ़ रहे हैं, सो यू हैव टू मैनेज योर गोल हियर GATE and ESE. After that, you will take any subscription plan, that is plus subscription, free courses, special classes. Okay, so हर एक subscriptions के अलग अलग फायदे हैं. आप लोग अगर अपना ये complete करना चाहते हो course, तो you can choose any one subscription which is very important. After that, press the get subscription and you will take a subscription plan. देखो यहाँ पे आप लोग सब्सक्रिप्शन प्लान ले सकते हो, जैसे कि 12 मंथ्स के लिए. अगर आप गेट 2022 के लिए प्रिपेयर कर रहे हो, 2021 के लिए प्रिपेयर कर रहे हो, तो आपको प्लान्स अलग अलग लेने होंगे. And for that, if you want a 10% discount on your subscription fees, so you can use my promo code, that is DSP, so that you will get a 10% discount on your subscription fees. Now the next last part, you can pay your subscription fees by using any one of this method. और सबसे बढ़िया बात यहाँ पे अपने बताने जा रही हूँ, अनअकैडमी का कॉम्बैट आ रहा है, कल तक ही रजिस्ट्रेशन है, सो बी फास्ट. तो ये स्टूडेंट के लिए बहुत ही अच्छी फैसिलिटी है. देखो यहाँ पे आपको कुछ ऑप्शंस दिए जाएंगे. यू विल सी हियर हाउ टू इंस्टॉल द. तो यहाँ पे आपको बहुत सारे क्वेश्चंस दिए जाएंगे. यहाँ पे आपका स्कोर दिया जाएगा, रेटिंग दी जाएंगी, लीडरशिप बोर्ड होगा, अमेजिंग अवार्ड्स है आपके लिए. सो जो जैसे भी आप लोग यहाँ पे आंसर्स दोगे, आप यहाँ पे इन्वॉल्व होंगे. विल कॉम्पीट विद द बेस्ट एंड विन अमेजिंग प्राइजेस. यहाँ पे फर्स्ट प्राइज है आपके लिए लैपटॉप है, एप्पल का मैकबुक का लैपटॉप है. देन सेकेंड प्राइज है आपका एप्पल का आईपॉड है. देन थर्ड है एप्पल के एयरपोर्ट्स है, राइट. देन 100 अमेजिंग टॉप रैंकर्स के लिए आपको 1000 रुपीज का अमेजिंग अमेजोन की तरफ से वाउचर्स है. सो मेनी एक्साइटिंग प्राइजेस है. सो प्लीज पार्टिसिपेट इन द अनअकैडमीज कॉम्बैट. ओके, हियर compete, crack and conquer the Unacademy's combat. So here first largest in India's largest 490 competition for GATE, challenging GATE questions created by best educators, super fast and fun with the real-time ranking, compete with the best, detailed video solution by top educators. So please enroll your, and enrollment यहाँ पे सबसे बड़ी बात है कि enrollment free है. So कल तक है December 16 6 PM तक. So please register, book fast, compete, crack and conquer. No. और भी सबसे बड़ी बात यहाँ पे मैं आपको बताने जा रही हूँ, इन्वॉल्व फॉर द गेट. जो भी आप लोग यहाँ पे 2022 के लिए प्रिपेयर कर रहे हो, उसके लिए सिविल ब्रांच के लिए बैच ए आ रही है, जो कि इंग्लिश एंड हिंदी दोनों में है, और 20 दिसंबर से स्टार्ट हो रही है. 11:15 सुबह 11:15 यहाँ पे बेस्ट टॉप एजुकेटर्स आपको यहाँ पे पढ़ाएंगे, जैसे कि शोभित श्रीवास्तवा है, अनिरुद्ध सिंह है, जसपाल सिंह सर है, दुष्यंत मीना सर है, राजपूत जोहरी सर है. तो यहाँ पे आप लोग अच्छे तरीके से पढ़ सकते हो, राइट. एंड ये बैच आपकी स्टार्ट हो रही है 28 दिसंबर से. प्लीज टेक सब्सक्रिप्शन प्लान फॉर दैट. और एक मैकेनिकल ब्रांच के लिए भी बैच ए स्टार्ट हो रही है, मैकेनिकल की इंग्लिश एंड हिंदी में है, वो भी 28 दिसंबर से स्टार्ट हो रही है, जो कि 6 PM की है. सो you enroll your names and take a subscription plan for to book the first seat in this batch. And to unlock the free plan of Unacademy, use my promo code, that is DSP, और स्पेशल क्लासेस, लाइव टेस्ट सीरीज, क्विज एंड अनअकैडमी कॉम्बैट के लिए. Okay? Now, we starts our actual topic, that is maxima and minima. Okay, we will see here maxima and minima. Now, the function u is equal to f of xy, the continuous and differentiable function of two independent variables x and y. The function u is equal to f of xy is said to have a maximum value at x is equal to a, y is equal to b, if f of ab is greater than f of a plus h comma b plus h, and it have a minimum value if f of ab is less than f of a plus h comma b plus k. Here h and k are very small positive or negative values. Okay, h जो भी है वहां पे स्मॉल वेरी स्मॉल पॉजिटिव और निगेटिव वैल्यूज है. नाउ सी, अगर आपका फंक्शन f of x y ये मिनिमम है, एट मैक्सिमम वैल्यू है एट x is equal to a and y is equal to b, if f of ab is greater than f of a plus h comma b plus k. Okay, and it will have a minimum value if f of ab is less than f of a plus h comma b plus k. H and k are very small positive or negative values. Geometrically, u is equal to f of xy represents a surface. The point of a maximum may be compared with the highest point of a dome, and the minimum point may be compared with the lowest point of a bowl. So sometimes at the point AB, the tangent plane is horizontal and surface descends in a certain direction and the ascends in other direction. Such a point is called as saddle point. It means the function is not maximum, not minimum at that point. That point is called as a saddle point. Okay. No need. See here, यहाँ पे दिख रहा है लोकल मैक्सिमा. सपोज दिस इज योर फंक्शन है, यहाँ पे आपका फंक्शन है, ये टच हो रहा है यहाँ पे इस लाइन को. दिस इज योर मैक्सिमम मिनिमम पॉइंट. at this point the function is minimum, and at this point the function is maximum. Okay, and it's somewhere you will get a point where the function is neither maximum nor minimum, that is your saddle point. Now see here, this is your saddle point, neither maximum nor minimum. The function is neither maximum here nor minimum, so this point is called as saddle point. So यहाँ पे अलग अलग टाइप भी एब्सोल्यूट मैक्सिमा भी होता है, एब्सोल्यूट मिनिमा भी होता है, बट यहाँ पे हम लोग लोकल मैक्सिमा एंड लोकल मिनिमा पढ़ेंगे. So local minima is look like this, local maxima is this. These points are called as the function is local maximum at this point and the function is local minimum at this point. The point at which the function u is equal to f of xy is either maximum or minimum is known as a stationary point. Okay? जो भी functions के point आएंगे आपको जो either maximum होंगे और minimum होंगे is known as the stationary point. The maximum or minimum value of a function is called its extreme value. Okay, the maximum or minimum value of a function is called its extreme value. Let the function of x and y of two variables which is continuous and differentiable in x and y to find maximum or minimum value, use the following procedure. Now see, first procedure very simple way से मैं यहाँ पे आपको बताने जा रही हूँ कि function का maximum minima कैसे find out करना है. Now see, first given the function f of xy is equal to 0, then find first differentiating the given function f with respect to x, and then differentiate the given function f with respect to y. So and third step is solve that both the functions dabba f by dabba x is equal to 0 and dabba f by dabba y is equal to 0. Now after differentiating these two, solve the equation simultaneously and find the values of x and y. Once you differentiate this with respect to x and with respect to y, then equate it to 0 and solve the equation simultaneously and find the values of x and y. Now x and y is equal to a1, b1, a2, b2 and so on, a3, b3 are called as stationary values. Now find r is equal to dabba square f upon dabba x square, s is equal to dabba square f upon dabba x dabba y, t is equal to dabba square f upon dabba y square. Now find r.s.t for each pair for a1, b1. राइट. हर एक पॉइंट के लिए मतलब r.s.t, एट दैट पॉइंट फाइंड आउट r.s.t फॉर द गिवन पॉइंट a1 एंड b1, जो भी हमने साइमल्टेनियस इक्वेशन सॉल्व करके जो भी पॉइंट्स हमें मिले, for that each point we will find out r.s.t. अगर r at a1 b1, r s at a1 b1, t at a1 b1, and seventh one, if rt minus s square is greater than 0 and r is greater than 0, then function is minimum. Remember this by using second order derivative test, how to find out the maximum and minimum value. If rt minus s square is greater than 0 and r is greater than 0, then the function is minimum at the given point ab. Okay, and we will get the minimum value, put that point in that function. F at a1 b1 is called the extreme value, and that value is your f minimum. Exactly similar way, if rt minus s square is greater than 0 and r is less than 0, then function is maximum at ab, and f at maximum is equal to f of a1 b1 is called the extreme value. And third one, if rt minus s square is less than 0, then the function is neither maximum nor minimum, then the point a1 b1 is called as a saddle point. Okay, I hope you are clear what you mean by maximum, minimum and saddle point. If the function is having rt minus, if your rt minus s square is greater than 0, r greater than 0, then function is minimum. If rt minus s square is greater than 0 and r is less than 0, then function is maximum. And if both is not possible, it means rt minus s square is less than 0, then function is neither maximum nor minimum, then the point a1 b1 is called as the saddle point. And if rt minus s square is equal to 0, need more investigation. It means this test is not applicable to find out the maximum or minimum value. Okay? Now let's see first example. Discuss the maxima and minima of the function x square 3x square minus y square plus x cube. Okay, we'll discuss the maximum and minimum maximum and minimum of the function 3x square minus y square plus x cube. So here we will find out. Go step by step. First of all, our first step is, here f is given. Your function f is 3x square minus y square plus x cube, right? Here 3x square minus y square plus x cube. So you will get dabba f by dabba x. Your first step is differentiating f partially with respect to x and partially with respect to y. So you will get dabba f by dabba x is equal to 6x plus 3x square, right? 6x plus 3x square. Similarly, for differentiating f partially with respect to y, you will get dabba f by dabba y is equal to minus 2y. Now equate these two equal to 0, right? So we will equate it to 0. So you will get dabba f by dabba x. Dabba f by dabba x is equal to 0, which implies 6x plus 3x square is equal to 0. Now take 3 common, so you will get 3x into bracket 2 plus 2 plus x is equal to 0. So either 3x is equal to 0 or x plus 2 is equal to 0. 3x is equal to 0 or x plus 2 is equal to 0, which implies either x is equal to 0 or x is equal to minus 2. Now for x is equal to 0, we'll find out x is equal to 0 here. Put any one of this, so you will get y is also 0. Put in this equation. So for x is equal to 0, you will get y is also 0. Implies y is equal to 0. So the point you are getting is 0, 0. First point is 0, 0. Now for x is equal to minus 2, you will get y is equal to, x is equal to minus 2, you will get y is equal to again 0. Now put in this equation, x is equal to 0, then y is also, x is equal to minus 2, then y is also 0. So your point is 0, minus 2, 0 is the point. So we got two stationary points. These 2 points are stationary points, 0, 0 and minus 2, 0. Right? We got these two stationary points. So we will find out first rt minus s square. So for that we will find out r. What do you mean by r? R is the second order derivative of a given function f with respect to x. So r is equal to dabba square f by dabba x square. So you will get here 6 plus 6x. So r is 6 plus 6x. S is dabba square f upon dabba x dabba y. So differentiating dabba f by dabba y with respect to x. So dabba f by dabba y with respect to x. Now this is constant. So derivative of this is 0. Right? r.s.t. So t is equal to, you will get here dabba square f upon dabba y square. So which is equal to, now differentiating this with respect to, so minus 2. We'll get it is minus 2. Now we will find out rt minus s square. Rt minus s square, which is equal to, now here r is, here you will get r is, can write here rt minus s square, we can calculate immediately. Rt minus s square, r is 6 plus 6s into t is minus 2 and minus s square. So here is 0, right? So you will get here minus 12 minus 12x. So rt minus s square is equal to minus 12 minus 12x. Now we will find out for the each point rt minus s square for the point 0, 0. Okay. First we will calculate for the stationary point. For the stationary point 0, 0. For 0, 0, first rt minus s square at the point 0, 0, you will get. So what is your rt minus s square? It's a minus 12 minus 12x, right? So put at 0, 0, you will get x is equal to 0. So it is minus 12. So rt minus s square is less than 0. Okay. Rt minus s square is less than 0. So this is, now second one, therefore the function is neither maximum nor minimum as it is less than 0. Therefore function is neither maximum nor 0, nor minimum, sorry, neither maximum nor minimum at point 0, 0. Okay, second one, rt minus s square at point, you are getting minus to 0. Minus to 0. So here minus 12 minus 12x at point minus to 0 is equal to, put x is equal to minus 2. So minus 12 into minus 2 plus 24 minus 12. So you will get here is 12, which is greater than 0. As minus 12 minus to 0. So therefore the function is, as rt minus s square is greater than 0 and r is, here we are getting r is, at that point we will find out r. Okay, so r is equal to, here we have r is equal to 6 plus 6x, right? At point minus to 0, so minus 12 plus 6, so again minus 6, which is less than 0. Now rt minus s square greater than 0 and r is less than 0, therefore function is maximum, as rt minus s square is greater than 0 and r is less than 0. Therefore, function has, or function is maximum. And the maximum value is, f max is equal to, the maximum value f max is equal to, you will get, put x is equal to minus 2, 0, you will get the value x minus 2, so minus 2 square, so 4 into 3 12, 12 minus 0 and minus 2 cube is minus 8, so the 4, 12 minus 8 will get 4. This is the maximum value of the given function at the point x is at the point minus to 0. Okay. Now here we will see, discuss the maxima and minima of the function x square plus y square plus 6x plus 12. Okay, discuss the maxima and minima of the function x square plus y square plus 6x plus 12. So you will get here f of x, f is given. F is equal to x square plus y square plus 6x plus 12. Right? So dabba f by dabba x. First job is calculate differentiating f partially with respect to x. So you will get 2x plus 6. Then dabba f by dabba y is equal to 2y. Right? Now different equating to 0. So dabba f by dabba x is equal to 0, which implies 2x plus 6 is equal to 0, which implies 2x is equal to minus 6. So x is equal to minus 3. Here one value, that is x is equal to minus 3, and put x is equal to minus 3 in this equation, you will get y is equal to 0. So the point is, first point is minus 3 0. Right? Similarly equate it this to 0, dabba f by dabba y is equal to 0, so you will get y is equal to 0. So ultimately only one point you will get, minus 3 0. Minus 3 0 is the stationary point. Minus 2 0 is the stationary point. Now we will find out the maximum or minimum value of this. So first of all, calculate RT. Dabba square f upon dabba x square. So here is 2s. Dabba square f upon dabba x dabba y. So differentiating dabba f by dabba y partially with respect to x, that is 0. T. Dabba square f upon dabba y square is equal to 2. Okay. Here r.s.t, here is 2. So calculate rt minus s square is equal to, so rt minus s square, so you will get directly here 2 into 2 4, minus s is 0, which is equal to 4. Now rt minus s square is greater than 0. So let's discuss function is, and r is equal to, so r is equal to 2, which is greater than 0. Now r is greater than 0, rt minus s square is greater than 0. As r greater than 0 and rt minus s square is also greater than 0 for the point minus 3 0. So obviously the function is minimum, and the f minimum function. So f minimum is equal to, you will get, put x is equal to minus 3 and y is equal to 0. So minus 3 square, that is 9, 0, minus 18, 9 minus 18 minus 9 plus 12, that is 3. So f minimum is equal to 3. Okay. I hope you are clear how to find out the maximum and minimum value by using the derivatives test. Okay. Now, third example, find the extreme values of the function x cube plus 3xy square plus 3x square minus 3y square plus 7. So extreme value, it means the function will have either maximum value or minimum value. Okay, so let's start. First of all, the given function f is, here f is equal to x cube plus 3xy square plus 3x square minus 3y square plus 7. Right? So you will get here dabba f by dabba x is equal to 3x square plus 3y square plus 6x. Right? Plus 0. Now dabba f by dabba y is equal to, here is 6xy minus 6y. Right? So dabba f by dabba x is equal to 0. Dabba f by dabba x is equal to 0, which implies 3x square plus 3y square plus 6x is equal to 0. If I take 3 common, so you will get x plus y plus 2x right? X plus y plus 2x. Ultimately here you will get y by x is equal to 0. 3 in bracket square plus y plus x square plus y square plus 2x is equal to 0, right? X square plus y square plus 2x is equal to 0. So here you will get, here is your function t minus 3x square. Here you will get minus 2x, minus 3x square. So minus 2x. So now equating this with respect to y. So you get here 6y common into bracket x minus 1 is equal to 0. So either y is equal to 0 or x is equal to 1. So put y is equal to 0 in this equation. So call this as equation number here equation number 1, here equation number 3. Put y is equal to 0 in equation 2. We'll get here 1 plus y square minus 2 x is equal to 1. So 1 plus y square minus 2 is equal to 0. So y square minus 1 is equal to 0. So y square is equal to 1. So y is equal to plus or minus 1. So for x is equal to 1, we get 2 points, x1 1 and x is equal to 1 minus 1. Okay, these 2 points we are getting for x is equal to 1. Now we will put for x is equal to y is equal to 0. So put y is equal to 0 in that. Put y is equal to 0. So you will get here from equation 2 x square minus 2x. So take x common. So either x is equal to 0 or x is equal to 2. So for x0 we'll get value y0 also and x y0. So these are the four stationary points. Not the four stationary point 0 0 1 1 2 0 and 1 minus 1. These are the four stationary points. We will check for the each stationary points. The function is either maximum or minimum. Now for that we required r. R is equal to dabba square f upon dabba x square. So what is our r? Here f dabba x is 3x square plus 3y square. Right? So here is minus 6x. So differentiating partially with respect to x. So you will get here r is 6x minus 6. R is equal to 6x minus 6. Okay. S is equal to dabba square f upon dabba x dabba y. So which is equal to differentiating partially with respect to x. Get 6y is 6y. Right? S is equal to 6y and t is equal to dabba square f upon dabba y square is equal to here 6x minus 6. Okay. So this is your r.s.t. Now calculate rt minus s square. Rt minus s square is equal to r into t 6x minus to t and 6x minus 6, right, minus s square. So minus y square. Now put rt for the point 0 0. Here rt minus s square is equal to 6x minus 6 into 6x minus 6 So 6x minus 6 bracket square minus s square is 6y square. Right? So RT minus s square is equal to this. Now first for the points 0, 0. For first stationary point 0, 0. So RT minus s square is equal to x0, y0. So you will get 0. So RT minus s square is equal to 0. X is equal to 0. Sorry. X is equal to 0 minus 6 square. So here is 36 is 0. So 36 is greater than 0. And r is at this point, r is value of r is equal to 6x minus 6, 6x minus 6.0 is equal to minus 6 less than 0. So rt minus s square greater than 0 and r is less than 0. So you will get here function is maximum. Function is maximum at point 0, 0 and f max is equal to, now put x0 y0 in the given function. Here is x0 y0 x0 y0, so 7. F max is equal to f at 0 is equal to 7. Now second one for the point we will say 1, 1. Okay, for the points here 1, 1. So t minus s square is equal to, now put x is equal to 1. So 6 minus 6 here is 0. Y is equal to 1 minus 6y. Y square. It is minus 36. It is less than 0. Right? RT minus s square is minus 36. The function is, as RT minus s square is less than 0, the function is neither maximum nor minimum. Okay, at the point the function at the point 1, 1 the function is neither maximum nor minimum because rt minus s square is less than 0. Okay, third one for the point 2, 0. For point 2, 0 rt minus s square is equal to, the point 2, 0 rt minus s square is equal to 6x minus 6, 6x minus 6 bracket square minus y square. Y is equal to 0, so this will become 0. X, uh, x is equal to 2. 12 minus 6. Again here is 36. 36 is greater than 0. Now calculate r. R is equal to 6 minus 6. Put x is equal to 2. So 12. 12 minus 6, 6. 6 is less than 0. Now rt minus s square is greater than 0 and r is less than 0. Then function has, sorry, r is greater than 0. I'm sorry. Function has minimum value at 2, 0. The point 2, 0 and f minimum is, now put x is equal to 2, y is equal to 0. Here put x is equal to 0, x is equal to 2, is 2 cube 8, y 0, so this will become 0 minus 2 square is 4, 4 into 3 12, there is y 0 plus 7. So 8 plus 7 15 minus 12, so 30. We will get here 30. F minimum is equal to, the point f minimum 2, 0 is equal to 3. 13 minus 5, no? 15 minus 12, 3. So f minimum is 3. Okay. Now for the point 1 minus rt minus s square is equal to 6x minus x bracket square minus 6y square is equal to x1 y1, x is equal to 1, so it will become 0. Y is equal to minus 1, minus 1 square plus 1 minus 6 is less than 0. Then rt minus s square is less than 0, so the function is neither maximum nor minimum. Function is neither maximum nor minimum at point 1 minus 1. Now, next is divide 120 into 3 parts. Very interesting, best application. So divide 120 into 3 parts so that the sum of their products taken two at a time shall be maximum. Okay, sum of the products taken two at a time shall be maximum. Now here, first one, divide 120. So let x, y, z be the 3 parts. Let x, y, z be the 3 parts of 120. Okay, so you will get x plus y plus z is equal to 120. So also the product of their sum of their products taken two at a time. So if I take xy plus yz plus xz, so is equal to is maximum is equal to f of x. So your f of xy, we have to check whether this function is maximum or minimum, right? So this is your f of xy. Now what is your z? Now we will convert into variable 120 minus x minus y, right? So you will get f of xy here. F of xy is equal to xy plus y into z. Z is 120 minus x minus y plus x into 120 minus x minus y. So ultimately we will get the function here xy plus 120x minus xy minus y square plus 120x minus x square minus xy. So if you observe, this will get cancelled out. 120x plus 120x plus 120x, it is plus 120x, and here is x into z, xy, yz and x, right? So ultimately you will get here you get f of xy minus xy minus x square minus y square 120 y 20y. So obviously f of xy is equal to xy or my xy minus y square minus x square minus y square plus 120y plus 120. Okay. For maxima and minima, dabba f by dabba x. Calculate dabba f by dabba x is equal to minus y minus 2x plus 120. Right? Now dabba f by dabba y is equal to minus y, there is minus x minus 2y plus 120, right? And equate it to 0. So after equating it to 0, we get x minus x plus 120 minus 2y is equal to 0. So obviously here you will get x minus 2y is equal to minus 120. So x plus 2y, get x plus 2y is equal to 120. All this is equation number 1. Similarly here minus 2x minus 2y. So 2x plus y is equal to 120. So this is equation number 1. Right? So after adding these two, we'll get x is equal to y. If I take here, so if I multiply this equation by 2, so 2x 4y is equal to 120. Here you will get 3x. So ultimately you will get here 2x plus y. Now RHS are equal. Can I write this as 2x plus y is equal to x plus 2y. 2x minus x, that is x. 2y minus y, that is y. So x is equal to y. Okay. So x is equal to y. Put one of this equation. So you will get, so call this as equation number 1, 2. Then x is equal to y. Can put here. We'll get 2x plus y is equal to 1. So 3y is equal to 100. Y is equal to 40. Okay. Again we'll put y is equal to 40 in that. So you will get here x is equal, when x is equal to 40, because x is equal to y, so size x is also 40, right? X is equal to 40. So from equation 1, from that equation you will get z is equal to, जो भी z का equation, all this is equation 1, equation 2 and 3. From equation 1 we get here z is equal to 120 minus y, right? So z is equal to 120 minus 40 minus 40. So you will get z is equal to 40. So the point is xyz. Therefore xyz is the point which is 40, 40, 40. So we have to check the given function is either maximum or minimum at this point. X is equal to 40, y is 40, z is equal to 40. So here you will get r is equal to dabba square f upon dabba x square. So minus 2 only, right? So r is equal to minus 2. S is equal to dabba square f upon dabba x dabba y. So differentiating dabba f by dabba y with respect to x. So minus 1 only. And t is equal to dabba square f upon dabba y square, which is equal to dabba square f upon dabba y square is equal to minus 2. Okay. So here is minus 2. Now calculate rt minus, so r into t, minus 2, 2 minus 2 minus s square. So here is plus 4 minus 1, 3. rt minus s square is greater than 0. And r is equal to minus 2, which is less than 0. Therefore, function has maximum value. Therefore, function is maximum. That's we want to prove. Function is maximum. Okay. Let's see the next one. That is, find the maximum value of x square xy plus a cube into 1 upon x plus 1 upon y. Okay. So we will see here f is equal to xy plus a cube upon x plus a cube upon y. Xy is equal to a cube upon x plus a cube upon y. Right? So you will get, for the stationary values, calculate dabba f by dabba x. So dabba f by dabba x you will get here. Differentiating respect, here is plus. So differentiating with respect to x, y constant, plus x a cube upon x square. So there is derivative of this is 0. So minus 1 upon x square and this a cube. Okay. And then dabba f by dabba y is equal to x minus a cube upon y square. So equate it to 0. So dabba f by dabba x is equal to 0. So y minus a cube upon x square is equal to 0, which implies x square y minus a cube is equal to 0. Similarly, xy square minus a cube upon y cube is equal to 0. Upon y square is equal to 0. So here you will get x square y is equal to a cube. And here xy square is equal to a cube. Right? So which implies x is equal to here x square y is equal to a cube and xy square is equal to a cube. So if I divide this, so you will get x is equal to y a cube upon y square. X is equal to a cube upon y square. Okay. So at the point x is equal to a cube upon y square, you will get here a cube y, a cube upon y square square, x square, right, into y is equal to a cube. So a raised to 6 upon y raised to 4 times y cube is equal to a cube, which implies y is equal to a. Okay. So the stationary point from this equation, you will get stationary point y is equal to a. So x is equal to a cube upon a square. That is x is also a. X is equal to a. So stationary point is a, right? So once you got the stationary point, calculate rt minus s square. So r is equal to dabba square f upon dabba x square. So our r dabba square f upon dabba x square. So y is constant, derivative is 0, minus 1 upon x raised to 2, x raised to minus 2. So minus 2 into raised to minus 3 plus 2a cube upon x raised to 3. Right? So plus 2a cube upon x is your r. Right? X dabba square f upon dabba x dabba y, which is equal to dabba square f upon dabba x. So 1 minus, only here is only 1 because of the constant. T is equal to dabba square f upon dabba y square. Again differentiating with respect to y, so this will be 0, and exactly similar way y raised to minus 2 a cube upon y cube. Right here 2a cube upon y cube. Calculate now rt minus s square. Okay. Rt minus s square, r is 2a cube upon x cube into a cube upon y cube minus s square. Right, so we'll get here 4 a raised to 6 upon x cube into y cube minus 1. Right. Now at point rt minus s square at point AA, x is equal to a. So 4 minus 1, that is 3. At point AA, here you will get rt minus s square is equal to 3. which is greater than 0. At point AA, RT minus S square is 3, which is greater than 0. Now, for AA, at point AA, R, get R at point AA, so R is equal to 2. And at point AA, S is equal to 1. At point AA, T is equal to 2. Point AA, R is equal to 2, S is equal to 1, T is equal to 2. Now here RT minus S square greater than 0 and R is also greater than 0. Right? RT minus S square is greater than 0 and R is also greater than 0. Therefore, the given function is minimum. Therefore, F is minimum at point AA. And the minimum value is, and minimum value is F minimum at AA is equal to, so here you will get F minimum at AA is equal to, now put just value of AA, xy. So here A into A plus A cube to bracket 1 upon x, 1 upon A plus 1 upon A. So here is A square upon A square plus A square upon this 2 upon A. So 2A square upon A. Right? A, so you will get here A cube. So 2A square, 2A cube upon A is equal to A square plus 2A square equal to 3A square. Okay. I hope you are clear here how to calculate the F minimum and F maximum for the given function f of x. So here is your maximum value F maximum and F minimum. So here you will get your application of, here is your application of partial fraction, that is maxima and minima. Okay, where is the functional value? अगर यहाँ पे आपका कोई भी function है, right? This is your F max, your F minimum, and this is neither maximum nor minimum at this point. Okay, I hope you are clear how to calculate the maximum and minimum value of the given function. Okay, once we'll take one more example so that it is more clear to you how to find out the maximum and minimum value of the given function. The stationary value of the function. Only stationary value we have to find out. Find, find stationary value of f of xy is equal to sin x plus sin y plus sin of x plus y. Okay. For the stationary value, da by f by da by x is equal to, there is cos x plus sin y के लिए है तो sin x plus y plus cos x plus y, and derivative of x plus y with respect to x is 1, is equal to 0. Now da by f by da by y, and next cos y plus cos x plus y equal to 0. Now equating these two, from these two equations, now currently your equation 1, equation 2, equation 3. From equation 1, 2 and 3, 2 and 3 get, yeah, from equation 2 and 3 we get cos x plus cos of x plus y is equal to cos y plus cos x plus y, right? So cos x plus y common, right? Cos x is equal to cos y, so which implies x is equal to y, okay? Which implies here x is equal to y. That's it. And once it is x is equal to y, so your equation, we see, as we get here equation is equal to y, find out the stationary values. So from equation 1, cos x plus cos 2x, x is equal to y, no? Cos x plus cos 2x is equal to 0, which implies cos x is equal to minus cos 2x. So cos x is equal to minus cos 2x. It means here guys cos of pi minus 2x or pi plus 2x, right? So which implies x is equal to pi minus 2x and x is equal to pi plus 2x, right? So here x is equal to pi by 3 and x is equal to minus pi. Hence y is equal to pi by 3 and y is equal to pi. Y is equal to minus pi. So the stationary points are pi by 3 comma pi by 3 and minus pi comma minus pi. Only we have to find out the stationary point, right? Only we have to find out stationary points. So stationary points are pi by 3 comma pi by 3 and minus pi comma minus pi. These are the stationary points. Okay, I hope you are clear, and then we will check whether the function is maximum or minimum at that point or not. So thank you so much. If you are liking my videos, please do like, share and subscribe. The next, I will be here with the next point, that is partial hit and wave equation, in the next lecture. तो यहाँ पे हम फिर से बता रही हूँ, यहाँ पे आपका न्यू बैच स्टार्ट हो रही है 28 दिसंबर से 11:15 AM को, okay, with the top educators of Unacademy. एंड ईयर 28 दिसंबर से 6 PM को ये बैच स्टार्ट हो रही है मैकेनिकल के लिए, ये सिविल के लिए है, ये मैकेनिकल के लिए है. सो प्लीज टेक अ सब्सक्रिप्शन ऑफ इट. And to get this subscription, to get the 10% discount on your subscription fees, use my promo code, that is DSP. Thank you so much.